A car starts from rest at point A. The distance of the car from A after t seconds is given by d equals t squared plus t, where d is in meters. Find the distance of the car from A after 3 seconds. And then copy and complete the following table. Well, if I complete the following table, I'll automatically find out how far away it was after 3 seconds. That makes sense? Now, here's how you do it without using the calculator. What you do is you say d equals t squared plus t. You can say d1, which is the distance after 1 second, is 1 squared plus 1, which equals 2. Okay, you can also say d0. What's d0, guys? Distance after 0 seconds is going to be 0. Then d2, 2 squared plus 2, which is 6. d3, 3 squared plus 3, which is 12. And then finally d4, 4 squared plus 4 equals 20. And then finally d5, 5 squared plus 5, which equals 30. How many of you did it that way without the calculator? Okay, 1 or 2 of you figured out you can do it that way. Now, another way doing it is to use your calculator, and instead of using d, you're going to use the table function. Instead of using d, you have f of x, and instead of using the letter t, what are you going to use? X squared plus x. When do you start? You start at 0. When do you end? 5. And look at the results you get. 0, 0, 1, 2, 2, 6, 3, 12, 4, 20, 5, 30. That means after 5 seconds you've gone 30 meters. After 4 seconds you've gone 20 meters. That makes sense? So, you're now going to draw this, graph it. Now, how high do I have to go on the x-axis or the y-axis? Have to go as high as 30. So, and as low and 5 across. Good man. $4.20 and finally $5.30. So I have to go. What you know is about all the numbers on the right hand side? They're all. Do they have anything in common? These numbers here. Huh? Kenny? All even or all up in twos is the other explanation. So if they're all up in twos, it makes my job quite easy. I can now get 15 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'll just put 16 in just to be sure. And what can I do with all 15 blocks? Every one is worth 2. And so do you see what I'm doing there, guys? Every block is worth 2. So if I was to draw the in between, it'd go 2, 6, 8, 10. Now that's 2 packed, isn't it? It's messier, so I don't put the blue ones in. So I'll leave them out like that. How many seconds do I need on the y-axis? Only 5, so I can really stretch that out. Make it easy to draw. Have to label them. So this is distance, isn't it? In what are we measuring distance in? Meters. And on the x-axis, am I allowed to just draw the first one and the last one? Why not? It's not a straight line. I can't draw the first and last one if it's a straight line. So 0, 0, 1, 2, 2, 6, 3, 12, 4, 20, and 5, 30, is it? And we got this here, didn't we? Oh, watch out for that. Wobbled a bit, didn't I? There. So, is what it is. done. The distance from A to B is 16 meters. Use your graph to estimate the time taken for the car to reach B. After how long is 16 meters? 60 meters is here, and it tells me to use my graph, so I'm getting 3.5 seconds. What did you guys get? You can't just round it off to nearest one. If it's halfway between 3 and 4, it's 3.5. Okay. Anywhere from maybe 3.4 to 3.7 somewhere, depending on your drawing. Part 4, 3.5 seconds, using our graph to estimate the time taken for 16 meters. Okay, what do you get for that? Now, draw this graph in this domain. Now, if I was doing this without a calculator, what would I have to do? F3, F4, F5, and what would I do every time? It's x squared minus 8 times x plus 12, isn't it? And because I'm lazy, that's it there, yeah? I would, but I actually know from experience that it'll just grab the graph and drag it all over the place on me. It's not my first time doing this. So, as you can see, what we'd have to do is we'd have to write this equation down how many times? 5 full times, okay? And then in every one of them, what would I have to do then? Fill in the number 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Now, and that's if I wasn't using the calculator. I'd do it manually and I'd get 12. The next one would be 5. The one after that, yeah? 0, is it? And what you get after that? And then after that? Yeah, and after that? Minus 3, and that's the end of it? Yeah, to 5. Now, you'd have to put each one in a calculator individually. Now, you can also do it like this. You can also go to your calculator and do x squared minus 8x, and it all goes for the drawn then, and then plus 12. Starts at 0, ends at 5. Now look at the numbers I get. 0, 12, 1, 5, 2, 0, 3 minus 3, 4 minus 4, and 5 minus 3. You have to write down all those points. 0, 12, 1, 5. Am I allowed to do beginning and end? Can I do the first point to the last point? Why not? Not a straight line again. So, there are my points. Now what do I do next? Draw them. What's my largest point? 12, isn't it? So start off with 12. And then what's my lowest point? Minus 4. Okay, so let's see what we can do here. 16 blocks will do us, won't it? So 12, 10, 8, 6, 4, 2, 0, minus 2, minus 4. Is that okay? Then draw your line. Everybody happy enough with that? Now, that's my axis there, and then we have what's 1 to 5, is it? 1, 2, 3, 4, and 5. What numbers do we need to put in? 0, 2, 1, 5, 2, 0, oh, so that's 0, 12, isn't it? Not 0, 2, 0, 12. So it goes this way. then back around. Are we happy enough for that? I'm a bit wobbly here, haven't I? But yeah, within reason, you'd have to be reasonably steady. So if I was in a test, I'd actually come back and then I'd fix it like that. I'd actually do that. You can rub it out and then just fix it along. No, no, a curve is never ruler straight. It's a curve. Okay, if you did a ruler straight, it looks something like this, and you lose tons of mark for it. It looks something like that. It'd be too jaggedy, wouldn't it? So it'd actually look terrible. So never mind that. Now, find the room temperature at the start of the experiment. So the whole experiment is about, the graph represents a science experiment that lowers the temperature of an object from room temperature to below freezing over a period of 5 hours. So you start at room temperature. So what is room temperature at the very beginning? So this is temperature in degrees, is it? Temperature in degrees Celsius. And then what's on the y on the x-axis is time measured in. Where did I get that from? Five hours. Okay. Now, what did we start off at? 12, didn't we? So we started off at 12 degrees. Find the temperature of the object after 1.5 hours. What's 1.5 hours, Ryan? 1.5 hours. And then go across. Halfway between 2 and 3. So 2.5 degrees is the temperature after 1.5 hours. Find the time taken for the temperature of the object to fall to freezing point. Okay, that's why I always use 3 blocks. I really stretch the graph, okay? Now, Charlie, what is freezing point in science? 0 degrees. So when does it hit 0 degrees? 2 hours in. So 2 hours for it to hit 0 degrees. Find the time taken for the temperature of the object to be at its lowest. When is that its lowest? 4 hours in. And finally, find the lowest temperature reached by the object in the experiment. It basically is, isn't it? -4 degrees Celsius. So I did questions 3 and 5.